inputting a PK study, the original estimate told me that the half-life was 12.75, the balanced. The updated tells me is 13.25. So is half an hour longer after adding this information. WOPs can adjust the different doses, and when you add the second infusion, you can change the body weight. So one user would recommend of the validation point is for in pediatrics. You can use again the updated PK or not. Let's use the updated PK. And then it tells you what the patient is currently on. Welcome, everyone. I'll go back where we left it. So I go to our patient, the test patient in the testing center. The two functions we will review today are sort of additional functions that are beyond the basic cycle. Basic cycle being inputting a PK study, obtaining an individual estimate, using it to build a treatment plan, and then offload the treatment plan on the patient app. So the patient can, by imputing their infusion, see their predicted concentration at any moment and get a sense of their safety, their protection during the day. And we have also seen that if patients do so, when they meet their doctor again, they can review together all the data on bleeds and treatment that they would have entered in the system. That's the basic cycle. Then we have some additional function that are there, hopefully, to make the treater and patient life easier. The first one is the first one I'd like to review with you today is the validation point. So if I go in the patient chart, where I can add the PK study, and I could add a PK study, for example, if this patient was now switching to another concentrate, and I could draw sample again, and I could add another PK study. Or if it's 1 year later, the patient is stable and well on that concentrate, but I'm drawing another factor measurement, I could add a second PK study by adding the infusion, the measurement, and then I could merge the old and the new study to make the prediction more precise. When I have such a point, a subsequent measurement of factor in a patient, say during a follow-up visit, or for any reason, I can also use that information to validate the PK. And I will try to explain what we mean by validate. But for now, I'll show you how it works. So I could add a PK study here, or I could add a validation set. Please note that this patient is on Covaltry and is treated with 2,000 units of Covaltry. If I recall correctly, is treated 2 or 3 times per week. Let's see in the treatment plan. The treatment plan tells me that the patient is treated on Monday, Wednesday, and Friday with 2,000 units. So if I click on Add a Validation Set, the system asks me which PK I'm going to validate. In this case, there's only one, so it's easy. But if there were more than one, this screen would show me all the PKs that the patient had, and I would need to choose which one I want to validate. And this icon here, let me see what this PK study was. There was a pre-dose, and then a 4 and a 24 hours. So let's assume that I've a 24-hour sample for this patient that I gather through clinical routine. So I say, okay, this is the PK I want to validate, and I want to add a validation set. This is like adding a new infusion. So I will tell that the patient infused whatever he did. In this case, let's say he infused the 2,000 units getting on prophylaxis. And let's assume he did the infusion yesterday morning. Yesterday was the 28th at 7 a.m. and was a standard infusion of 3 minutes. When I'm done with this, I can save the infusion. And now I have here a validation infusion. Now, the infusion is not enough to validate. I need a measurement, like for a PK study. So at this point, I add the measurement, and let's say that the patient was in clinic today, so 1 day after, and around 7:10 or 7:10, we collected a sample, and this sample was resulted at 15%. We save that information. So I have a new measurement done on the same dose, and I validate the previous PK against this information. So I'll click on validate. The system asks me if I know about the treatment regimen for the patient, the previous infusion. For the sake of brevity, I will say yes, this patient is on this treatment. And when I'm done, I'm ready to submit the validation point. If I do submit, this goes to WOPS, to the PK engine, and the PK engine re-evaluate what would have been the concentration of factor VIII for that very moment based on the previous PK. So it runs again the estimation using the individual profile and calculating, like the app would do, the concentration for the same time for which I've entered the information. There's no validation. There's no human being this time. You know that for the PK, they go to either myself or Andrea Edginton, and we check if there were data entry error or if the model had some flag for us and so on. In this case, there's nothing, because this is exactly the same calculation that would provide the graph on the patient app. So we just let it happen. So you say, okay, and now you can view the validation result. So is you and WOPS. There's no one in between. If I click on view, what you see is a graph like this that shows you where that point is. Now, I don't know if you can read, it might be too small, but if I go with the mouse over that point, I don't only see the estimated. Yes, the estimated was estimated at 139, so 13.9% is down at the bottom of this box. The validation, the value I measured in the lab and I entered in the system, is reported above and is 0.15. So the system tells me they are not identical, but they are very close. The system also does for me a statistical validation. It tells me that at this time, 24 hours after the infusion, the predicted concentration was 138, and the prediction interval, so the space where this value was expected to be or could be, you know that estimation and individual PK profiling with POP-PK is a forecast, is a prediction. So it has some variability. And in this case, the variability is expected to be between 10 and 18. We are telling the concentration should be 13.8, but it could be anywhere from 0.10 to 0.18. What you measured is 0.15, which is, a 1% difference and is within the prediction interval. So statistically, this is no different. This is a good, is a positive validation. We have shown that the prediction is close to the measure. If this is clinically relevant or not is not for WOPs to tell, is for you, for the treater to tell. So at around 15% is different for this patient to be at 13.9, like the phone shows, or at 15, like the measure from the lab tells me. We don't know which one is true, by the way. The lab has their own measurement errors. Now, if this was a patient on mine and they had no bleeding, I would say this is not clinically important. I would not do anything different, knowing that the patient is 14 or 15%. I would do exactly the same. So I would call these non-clinically relevant. Could be different if this was, I don't know, 3 and 6, above and below a 5% threshold, or whatever it is that you can think of. This is not a statistical decision. This is a clinical decision. Now, you see up here that I can see the validation point. This is now orange. I could go back to see the estimate. I can see the validation point. I cannot see the updated PK estimate, because the system is trying to invite me to tell me if I feel that difference is clinically significant or not. You'll see that if I say yes or no here, in this case, I would say no, is not clinically significant. Now, this updated estimate is available to me. I can click on it, and I will see the 2 point here. So the 24 that I've added now, and the 28 that was there from the original PK. The original PK added 28. Now the validation point you see is indicated here with an asterisk, was added, and now is part of the PK. So by using the validation point, I do 2 things. One, I add the information to the set of data that the patient has. So this profile now this estimate is now based on 4 points and not 3. And at the same time, I'm using that point to check the quality of the prediction. Of course, the estimate may be changed. So let's check what was the original estimate. The original estimate told me that the half-life was 12.75, the balanced. The updated tells me is 13.25. So is half an hour longer after adding this information. Last thing I want to show you about the validation point is that if I go to the clinical calculator now, there's a new button here, use updated PK. I can estimate treatment regimen for this patient, either using the original PK, or if I click here, now using the updated PK enriched by the validation point. All the rest stays the same. Okay, so when would you use these? Well, you would use these if you are curious and you want to know how good WOPS is, or how good an individual PK profile is. And of course, you need to have a measurement made in one of your patients. I showed you a case where the patient is still on the same regimen. I added the same dose, but WOPS can adjust the different doses. And when you add the second infusion, you can change the body weight. So one user would recommend of the validation point is for in pediatrics. If we are now 1 year down the road, the patient is still on the same concentrate, but is on a different dose, and it has a different body weight, different height, I can add the validation point using the new parameters, the new dose, the new weight, the new height, and WOPS will adapt that point to the current profile, and that will, at the same time, help me check if that PK is still valid for that patient, and will update the PK to be more fitting better the new patient characteristics. Okay, let's move back to the patient. I can show it from here, and then I'll show you where else you can see it. So let's move now to the switching tool. What is the switching tool? The switching tool is a powerful instrument that is meant to help us around switching patient from one concentrate to another. We have discovered, thanks to all the data that you have provided through OPS, that there are some characteristics of the patient way of handling factor concentrates that carry forward from one concentrate to another. We know some of the determinants, say, von Willebrand factor, or age, weight, blood group, if we don't have von Willebrand factor. All of these are somehow affecting the shape of the curve. And we know that patient responds differently to different concentrates, so it's not completely predictable how they will perform on a new concentrate. But let me tell you like this: it is if you use the switching tool, you will see what is the likely profile, so the likely half-life of a patient going from a known profile on a known concentrate to the new one. That estimate is not perfect, but is much closer to what the reality will be than just assuming that that patient will have the half-life that is on the product box, on the leaflet in the product package. Because that value that is in the product package is the median. So technically, a very small group of patients has that half-life or that profile. That's the median profile in the population. Usually, no one has the median profile. 50% of patients are somewhere lower than that, and 50% of patients are somewhat higher than that. There will be some very close. There will be some that are exactly on the median. But in general, the population is spread around the median, and there are half below and half above. The prediction that the switching tool provides is on the right side of the median and is closer to the individual real profile than just the median would be. So it helps us understand if that patient will gain a little, a lot, or sometimes will lose by switching from concentrate A to concentrate B. How does it work? So you see that there's a tab up here that is switching tool. If you click on switching tool for a patient that has a profile, you will see that, again, there is a PK that is proposed to you, and is the PK that is used to be the treatment plan active for the patient. So this should be usually the one you want to use. The system gives you a chance of checking if there's any misunderstanding. In this case, the patient has only one PK, so we don't have anything to do. And then you have the age, weight, and height of the patient. We can use, again, the updated PK or not. Let's use the updated PK. And then it tells you what the patient is currently on. It says he's on 2,000 units, Monday, Wednesday, and Friday. And the first check that you could do is, in this case, we are considering switching from Covaltry to GV. So from a standard half-life to a long half-life. It tells you, are you interested in seeing what would happen if you keep the same dose and the same frequency? And I don't know if this is of interest to you, but let's see what happens if I ask the tool to calculate. what happened is that I get a double graph where I have in green Kovaltry, the current profile, and I have in orange GV. And in this case, you see on the graph that you get higher peaks and higher troughs. And in this specific switch, GV is at the same dose, same frequency, giving higher values than Kovaltry at any given point in time. Now, you could ask to see the confidence interval. It gets pretty murky. And it shows you that there are cases where even for this patient, if the PK on Kovaltry was the best possible one, the dotted green line, and the PK for GV was the worst possible one, he could actually be doing better on Kovaltry than GV. So when you add the confidence interval, you see really all the spectrum of potential. And it also is good to look at this confidence interval really to see how much variability is in the prediction. You see that for Kovaltry, the confidence interval are smaller. And the reason is that we have measurement. And so we know more or less where the patient is. For GV, we are assuming using the patient covariate, his weight, height, blood group, and so on, and all what we have learned by seeing him on Kovaltry, but we don't really know. We don't yet have measurement. So our uncertainty is larger. When I discuss with patients, I usually prefer this graph. It's simpler to understand. There's also a table down here that tells me that, for example, the peaks for Kovaltry are around 0.7, 0.7 on the Monday after the long interval, 0.73 for the other two. For Kovaltry will be around 9.2 on the Monday after the long interval and around 1 for the short interval. The trough for Kovaltry was already a very good trough, 2% on the Friday and 4 and 4 on the Monday and Wednesday. For GV, the trough is around 11% on the Monday and Wednesday, and 4% on the Friday. Weekly consumption, both 100% above 1%, above 3% with GV all the time, with Kovaltry 90% of the time, and about double the time above 15%. So I could save this treatment plan, even if it's predicted, and say today I'm switching the patient, I don't have yet measurement, but I want him to continue use the app. I could save this treatment plan and give it to the patient. Now, let's do some other exploration. So one thing is this patient is switching because they would like to go on twice a week. So let's change this to twice a week. Let's say we plan to treat the patient Monday and Thursday. And of course, we'll plan to give him, say, 3,000 units. So to keep the 6,000 per week, but decrease the frequency. And now I ask to calculate. And first of all, I have a warning. The system tells me you can't do this with Kovaltry. You are going below 1%. But I have no flag for GV. And indeed, by treating every 3 days with 3,000, I go below 1% with Kovaltry, but I don't with GV. And if I look here, the peak for Kovaltry would be around 1, the peak for GV will be around 1.3. The trough go close to 0.1 on the long interval. And stays instead above 2 for GV. So again, I would keep the patient above 1% all the time after the switch. The time above 3% will not be 100% like on every other, on 3 times a week, but will still be 96%. And more than half of the time, it would be above 15%. So this could be, for example, the treatment I want to say and give to the patient. What else can I do with the switching tool? For example, I may ask the switching tool, like we can do with the calculator, to give me a preferred dose. So let's say I'm considering to treat the patient every 3 days. I usually like to compare similar treatment on both sides. So every 3 days, and I want to target 3%. And of course, what I'm asking the system is tell me the dose. So again, 3% on both sides. And what I want to know is the dose. If I ask the system to calculate, you'll see that for GV, it predicts the need to reach a very high peak concentration around 1.5 to stay above the 3% at 3 days. With GV, a much lower peak. What you expect that will be a very large difference in the dose required. And indeed, if I go here, the weekly dose for Kovaltry would be around, the unit dose would be around 4,000 units. For GV would be 1,500. If I give these doses every 3 days, 4,500 or 1,300, I get a peak of 1.5, a peak of 60%, and a trough of 3%. And of course, I would have 3 times less consumption with GV as opposed to Kovaltry. And of course, the time above will be very similar, because in this case, you see, there's a much larger time at higher value, but then on the tail of the curve, they become very similar. Now, if I'm fine with going 3%, and this is what I like to use for the patient. I usually don't like to prescribe 1359. So what I would do in this case, I would go back here saying, I want to use every 3 days, and I want to give 1,500 units. I can put the same or different on this side. It doesn't really matter, because I'm interested in this one. The dose that the system calculated for me was approximately 1,500. So I'm now asking, can you make a plan with 1,500? And this is what the system produces for me. 1,500 every 3rd day is a peak of 7, trough of 3. I'm taking down the consumption for the patient, good protection. This is what I say. And I'll call it GV 1,500 IU per kg every 3 days, just for my own internal use. And now I've saved the treatment plan. Now, if I go back to the patient and I go into treatment plans, I find now this plan here. And you see this flag. It tells me this is a switching tool generated plan. What does it mean? Well, it means this is an estimation on Kovaltry and a prediction on GV. It is not as reliable as an individual PK profile obtained by using measurement. I can still use it. I can now move this one as the active, and that will go to the patient app. And if I'm switching the patient today, he can start using he can continue use the app, and he will use, we'll see prediction for GV. But the suggestion is that as soon as you have a chance, say a month later, if you do a clinical follow-up, or whenever is possible, you get at least 1 point and you go back and do the validation procedure. That validation will tell you how good the prediction was and will update the prediction with the validation point. Or you can draw 2 or 3 data points and do a new profile on Gini and compare the one that was predicted with the one that was estimated. So this is the end of my presentation today. I hope that this was useful. I understand these are 2 more complicated functions, but I invite you to try them out because I really believe that they can help you in decision-making with your patient.